Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. This is a bicyclic structure, norbornane skeleton, with a OCH2O bridge forming a cyclic 1,3-dioxylane type system fused into the bicycle. The methylene carbon, CH2, bears two oxygen substituents. This is a cyclic acetal. Moving on to the next step. This is a fused bicyclic compound with two ring oxygens in a 1,3 arrangement at the ring junction. The carbon at the ring junction bears two oxygen atoms, one from each ring. This constitutes a cyclic acetal, like a 1,3-dioxane fused system. Acetal. Moving on to the next step. This is a spiro compound, 1,4-dioxaspiro, 4.4 nonane, where the spiro carbon is bonded to two oxygens in a 1,3-dioxylane ring. The spiro carbon bearing two oxygens is the acetal carbon. This is a spiroacetal. And for the final step. This is a 7-membered ring, oxpane, with a carbon that bears both the ring oxygen and an exocyclic OCH3 group. That carbon has two OR groups, one as part of the ring O, one as OCH3. This is a mixed cyclic acyclic acetal, hemiacetal methyl ether type. Acetal. The structure shows a cyclopentene ring with a side chain carbon bearing H, OCH3, and OCH3. This carbon, CH, OCH3, 2, attached to the cyclopentene ring has two methoxy groups, which is the classic acetal, dimethyl acetal, pattern. Acetal. All 5 compounds, I through V, contain a carbon bearing two OR groups and therefore all qualify as acetals. None of them should be excluded from classification as an acetal. Why other options fail? A. 2 and 3. Both 2 and 3 are legitimate acetals, cyclic and spiroacetals respectively, so excluding them is incorrect. B. 4. Compound 4 is a valid acetal, cyclic acetal with exocyclic OR, so excluding only 4 is incorrect. C. I. Compound I is clearly a cyclic acetal, so excluding it is incorrect. Therefore, the correct answer is D. Therefore, the correct answer is option D.